Hello everyone, this is the Willingdon Observatory with another broadcast. Tonight I'm going to look at Mars. The thing here is to video Mars, and then I'll probably pause the recording and show you how to process it afterwards. So first of all, let's see what gear we've got at the moment. So I'm using a Mattel. Here we are. Telescope there, the short fat one, and I'm actually using an old Celestron Neximage Webcam. If I come back to this here, let's have a look at this picture. So that picture there shows the Neximage on the back of the telescope. Anyhow, best thing to do is go back to our screen. I've got the scope all set up. So here we are now. You can see I've got an image of Mars in front of me. I just had it cropped there, so there's the full image I'm getting at the moment. It's a 1750mm focal length 8-inch scope, and I've got a ×2 Barlow on it, so the image is twice as big as you get without the Barlow. You can stack Barlows. I have tried double stacking 2×2 Barlows, but you lose a lot of quality in the image. So I've gone back to just one Barlow. That's the sort of image I get from my scopes. Bigger scopes might give a sharper image. If I just go in and out of focus, you can see what's through focus for the other side. And that's about in focus. I've not got anything to help me focus, just my eyes. So that's the size of image I'm getting. And to image planets, rather than using long exposure cameras, you use very short exposure cameras, like video cameras or web cameras. So I've got this old Celestron Neximage camera. It's over 10 years old. It's working in, this is running on a Raspberry Pi, and it's running in a program called OA Capture, which seems to work quite well. I'm saving the files in the .ser format, so they can be processed by Registax later. So you do play around with the controls to try and get a good image. So for brightness, so here brightness makes it, you can go too bright. You don't want as much gain. You want the gain as low as possible, really, because gain is noise. And then you have the exposure for how long the actual frames are. So you can toy with these until you get what you think is the best image. Then what you do is record it. So I'm going to start recording this image at the moment. You need 2,000 or 3,000 frames. That's what I do anyway. And so you can see it's counting away at the bottom, frames. So it'll take a couple of minutes for it to record all the frames. As you can see, the scope is tracking, but you still get slight movement because it's not perfectly polar aligned. It's not bad. But the wobbles you see are mainly caused by the atmosphere, the Earth's atmosphere. Although Mars is quite high up at the moment, about 40 degrees, it's about 1:45 on the night of the 6th of October, which was actually the point of closest approach of Mars this year. Mars opposition is on, I think it's the 13th of October. So because Mars has a more elliptical orbit than the Earth, then oppositions and closest approaches don't always tie up. And so we've got closest approach today, and opposition is in a week's time. There are other better closest approaches. This isn't actually the best one. And so we're up to 1100 frames. And Mars also rotates. All planets rotate, some faster than others. We rotate once every 24 hours. So when you image Mars, you can quite often get a different face facing you. and of course if you take too long an image you'll get blurring. Jupiter's good for that because Jupiter's only got a 13-hour day, therefore it rotates a lot faster. Mars isn't that fast. Right, okay, we're up to 1700 frames. I did take like I say, a double stack Barlow image earlier as well. I might try stacking that, but I don't think it'll come out quite as well because it just looks a lot more blurry. So there we are. So that's about 2000 frames. So I'll stop that. So that is what I'll process in Registax later. What I will do is I'll pause the video now rather than do all the palaver of getting the files into the right place and getting Registax running, because Registax runs on Windows, not on a Raspberry Pi or a Macintosh. So I have to run a Windows virtual machine to run Registax. So we'll come back to that later and I'll tag it on the end of this video so we can see how to process the actual video itself. So bye for now, I believe this is. So see you shortly, hopefully. Okay everyone, here we are back again. It's now 10 past 1 in the night. So I've now moved the files over from the Raspberry Pi and I'm going to show you what to do with them. So I've got a virtual machine running on my Macintosh of Windows. I've discovered that Registax has problems stacking some of the files that are produced by this OA capture. So what I now do, I use AutoStakkert to stack the video, and I use Registax with its clever wavelets processing to do the magic at the end. So what I do here now is we start up Registax with nothing in it. I go to, I'll go to AutoStakkert, here it didn't crash. Try again. AutoStakkert. Let's open the file I want. So that was the last one we took. Open the file, I think it's about 2 gig. So there's a single frame. We can tell it to place alignment points automatically. So we'll do that and it sets all the alignment points. And then we tell it to analyze all the frames. So the noise is the fan from the laptop because it's doing a lot of stuff. So here we are, we've analysed all the frames. And now we'll tell it to stack them, so I'll click the stack button. We told it to ignore 50% of the frames, the worst 50%. Various options, you can change things, I'm leaving most as default. So now it's going through the stacking process. If I set this up correctly, it'll actually throw the stacked image into Registax. Fingers crossed. Yeah, so we are behind here, we've got Registax. It says stretch, I don't bother stretching here, I've not bothered trying it before. So there's the stacked image. Okay. So now it's taken straight to the wavelets processing within Registax. Wavelets seems to be magic, who knows how it works. My plan here is if I crop the image at some point, so there's a cropping thing. And these here on the left are the controls for the wavelets. And what I've tended to do is just pull the top one all the way to the right. You see the image got a bit sharper. And pull the second one all the way to the right. The image got sharper again. Third one will be pulling about halfway. Now, if you overdo these, then you spoil the image. It sort of does too much. And this is part of the art of how you produce an image of things. So now I do a do all, which runs everything, and I can save the image. It saves it as a JPEG in this case. And where is it going to save it? I've got no idea at the moment. Now I want to save it in the high level directory up there. That's okay then, so I do a save there. So that's saved. If I come out of Windows, actually I won't come out, I'll just swap find it. So here is the image we just created. Oops. And there we are. That's the image of Mars. Get rid of that one. Don't need that, do we? Yeah. So one produced image. Looks like we've got the South Pole at the top. Different bit features on the surface of Mars. We can always turn the image the other way around. Rotate it in. So it's south at the bottom. And there we have. All you can do now is compare that with other images of Mars that you can see around the internet. So there we have it. Because the camera's got low resolution, you don't get a very big image at the end of the day, but it's good enough what I'm trying to do. So let's go back here. So back to the camera. So that's it for tonight. Thank you very much. I hope you enjoyed it and learnt something. So goodbye and see you next time.